Okay, homework 5 is available. It's due next Saturday.
I have a quick question.
Yeah.
When will the Zoom from Tuesday be posted?
It should be posted. Let me check it.
Okay, and how do I find it? I just
Go to the modules and then scroll down to week 9. And then there's a Math 121, Math 121, 3:30. I'm clicking.
okay, and that's the one for the homework for that to do on Saturday.
Yeah.
Okay.
Yeah, actually, all of the meetings that we have available are in the modules. And if we missed a meeting, I made a note of it. And I can write down the test date one more time, just as a reminder. Let's get this done. Exam 2. Plus, I need the calendar. It's 4/6/21 to 4/15/21. And the next week is review for the test. So, any questions?
Professor, you said we were going to go over like 3 or 4 more examples, and then will we be just stopping there, or will we get a head start on the review? I'm fine either way. I was just wondering because you said we only had like 3 examples, and you wanted to start next week for review.
I think after the examples, I might I might talk about the empirical rule, but it's not on the test. It's just on the side. And then we'll call it for today.
Okay, cool. Yeah, I just want to confirm. Thank you.
Yeah, it's good. Okay, so I didn't get a chance to type up the examples, and it's kind of wordy, so we'll get through it together. Alrighty. Oh, I forgot an eraser. It's okay. Okay. And just before we get going, test questions will be like homework questions, just not multiple choice. And also the review will be like a good preparation for your test. So we'll make sure everything is clear, what kind of questions you're going to be asked. Okay.
Professor, can I ask just one question about
Yeah.
like the setup, possible setup? I know that I know for the homeworks, and I think for exam 1, you kind of do the questions in ascending order of when we like learn the stuff. Where like you can go, at least for me in my notes, you can go in order of kind of like, you know, you don't have to like switch back and forth through pages. So if you do that again, that would be awesome because it really is helpful.
That's the plan. Yeah. It helps me too to think through like,
Perfect.
grading and yeah. Okay,
Cool.
so
Thank you.
sure, yeah. So these look like word problems, but they're really just very wordy. It's going to be the same kind of ideas that we've been doing. So the first one, the length, actually, you know what? Let's go to, we're going to go backwards. The average number of calories in a chocolate bar. Is normally distributed with the mean, mu,
In the terms of base wording, Professor, is I guess the phrase the average number of calories kind of taking place of the random variable in like the ones we've been writing?
yes.
Like do you know what I mean? Okay, cool.
And I'll make it clear too, like I'll even put down what the variable is equal to in the problems. Mu, we've seen this before. This is going to be 225. And then suppose the distribution, wait, the average okay, actually, I'm trying to kind of, it looks good so far. I've just kind of reworded it. We've already got the normal distribution and we've got the average. Okay. And the standard deviation is sigma equal to 10. Your random variable x, which I do this capital X like this. The number of calories in a chocolate bar. Let me check this. We should reword it. Okay, because the way it was mentioned before, it would, that is a random variable talking about the average. So the way I've written this is not quite clear. Back up to here. So and I'm focused in on this problem now, so it shouldn't happen again. Is mu sub x equal to 225. Great. Okay, so we're actually going to talk about the distribution of the calories being normal. There is a place where you could talk about the distribution of the average of the calories being normal, but that's not what we're doing. We're over here saying, assume that distribution of calories is normal. And we have a mean, or we had the mean already, so the standard deviation is 10. Hopefully we can see everything. All right, so we're going to let X be the number of calories in a chocolate bar. Okay, so that's the random variable that has this normal distribution. And we're going to draw the picture with the mean in the center, and we use the standard deviation. And actually, all of that helped me to find areas under the curve. So I found that which maybe I'll talk for a second about how I get these numbers, but first we'll just put the number down. So then the probability that I randomly selected chocolate bar will have less than 220 calories is 0.03. Okay, and then in math, we're going to write that P for probability of a random variable X, the number of calories in a chocolate bar, being less than, so this symbol, less than 220 equals 0.03. We'll do like this. I'll write it again at the top of the board. So probability that a randomly selected chocolate bar has the number of calories less than 220 is still too big. Equals 0.03. Okay, so we'll come back to writing the rest of the problem in just a second. So I mentioned before that not every experiment has a normal distribution, but a lot of them do. And what was done in the past was a standard distribution, which is centered at 0 and has a standard deviation of 1, had a table called a z-table. And every other experiment gets transformed to be, is standardized to be that distribution. You use the table to get the area, and that area matches the area under the curve, which we've been talking about is that probability for that interval where your variable is. So that's what I've done on the side is I take something like this, I standardize it, read a table, and get that number. I'll just be sharing these numbers with you, so you don't have to worry about using a Z table or a calculator. So after I tell you this part, I will ask. The opposite, the probability that X is greater than or equal to 220. Okay, so what we're looking for is the probability that the number of calories in a chocolate bar will be greater than or equal to 220. So at the beginning, I talked about having a normal distribution, which is a bell curve. This is our random variable. And the mean is in the middle. It was a mean of 225. And we talked about an interval of X being less than 220. So your X values are going this way, which means we want this area right here equal to 0.03. And then you need to find the probability that X is greater than 220. So the area that's not shaded for those X values over here going this way greater than that number. You need this area. Okay. So the full area is 1, and then subtract that extra piece, that piece of area that's 0.03 to get the leftover part. It's going to be 1 subtract 0.03. Okay, but we're going to work through it. Probability that X is greater than or equal to 220 equals 1 minus the probability that X is less than 220. We wrote that that's 0.03, so take 1, subtract 0.03. I got 0.97. So with these questions, I'll mostly be asking you to use the complement rule, this rule right here. And okay. So that's the end of that one. The next one will be about the average admission charge for a movie. we're good with this part. Actually, any questions or concerns about this picture or problem? Okay. Oh, there we go. Cool. Let's go. Okay. The average admission charge for a movie is $12. The distribution of admission charges is normal with a standard deviation of $2.50. All right, so given that information, the probability that a randomly selected admission charge is less than $10 is 0.2. Back up to here. Randomly selected. Admission charge. Is less than $10. Oh, it's less than $10 equals 0.2. All right, then find, oh, actually, we're going to write what that means, and we're going to define the variable, and then we will find probability that a randomly selected admission charge will be greater than $10. So first, let's do the variable. Admission charge, whatever it is. So in these problems, I'm the one who's been using the standard deviation to get those areas, but it's still, interesting part of the problem, but it's kind of extra info for the homework. Okay, the probability. So probability that a randomly selected admission charge is less than $10 is 0.2. We want to find probability that x is greater than or equal to 10. So the chance that a randomly selected admission charge is greater than or equal to $10. So it's a normal distribution, which we'll draw. The mean was 12. And then the number we're kind of starting the interval at is 10. So at 10, but, well, actually it really doesn't matter if you include 10 or not include 10 with probabilities, but to be kind of specific, we're not including 10, we're going this way. So for that interval, we have a probability of 0.2 or an area under the curve of 20%. Probability that x is greater than or equal to 10. So on this interval here, we want a probability or an area under the normal curve. So that area is 1 minus 0.2, which is 0.8. So what happened was we took the probability of x being less than 10 and use the complement rule. We always take 1, subtract probability where x is greater than or equal to 10. Oh, doing this backwards. Okay, they told us that part. And we need the other piece. Oh, which means x. We need this piece. Okay, and I was given this information where I need that area where x is less than 10 is 0.2. Greater than 10, 1 minus being less than 10. We'll put in that number, we get 0.8. Okay, last one for chapter 17. It's number 3. The length of a steak is normally distributed with a mean of 42 inches. This problem was specific to like a California king snake, but we don't need to write that all out every time. So we're just going to simplify to snake is normal. Distributed. With a mean of 42 inches. Okay. And a standard deviation. Where is and it equals 9 inches. Let X be the length of a snake. Then the probability that a randomly selected snake is greater than 30 inches will be 0.9. Is greater than 30 inches is 0.9. Awesome. So I've already got my variable, and I'm going to write this up with that P for probability. Probability of the length of a snake being greater than, so this way, 30 equals 0.9. And then I'm asking you to find the probability that a randomly selected snake will be less than 30 inches. So find P of X less than, and you can have strictly less than or less than or equal to. It's not going to change the overall area. What do you have, 30? So I'm going to draw the picture and I'll write down the answer. And that's kind of the end of the examples. Again, we'll do more examples next week. Cool. So we have a picture. I think this is good. The mean is 42. We're going to start the interval at 30. And we want numbers that are greater than 30 for that area right there. So here and over. Go straight up to the curve. So for that interval, the probability is 0.9, or the area under the curve is 0.9. And then you're looking at x values less than or equal to 30 and getting that area under the curve. So we take 1, the full area, subtract 0.9, and it leaves that leftover piece that's not shaded. To get 0.1. Okay, so probability that x is less than or equal to 30, and then apply the complement rule. Where you take 1, subtract the probability that x is greater than 30. So minus this part here, 0.9. And that's going to be 0.1. Okay. So I'm going to check really fast just make sure I know the 3 parts to the empirical rule, but these notes are just on the side. Now that we've talked about the normal curve and standard deviations, I'd like to share this fun fact with you, because the next part that we do for the 3rd exam has nothing to do with any of these topics that we've covered. Okay, so empirical rule.
So we
So
could just simply just watch you explain it, right? We don't have to take notes.
yeah, you don't have to take notes. I think it's just interesting. So there are 3 parts, and the first part is that there will always be, let me double check. 68% of the area under the curve within 1 standard deviation of the mean. So I'm just going to kind of sketch these parts of your normal curve. Centered at the mean. And then we take 1 standard deviation in both directions. So take 1 standard deviation away from the mean. Add 1 standard deviation to the mean. And within that range, you will always have 68% of the area under the curve. And then 2 standard deviations captures even more information, and 3 standard deviations is almost all of the area under the curve. So second part. So you have the mean, and then subtract one standard deviation, and then subtract another standard deviation. You get to mu minus 2 sigma and mu plus 2 sigma. And it's been proven that the area under the curve on that interval is 95% or 0.95. And the last part, I'm pretty sure it's 99.7, but I just want to double check. 99.7. Okay, so if it's a normal distribution, where your center is the mean, and you go 3 standard deviations from the mean in both directions, you have 99.7 point, well, 99.7% under the normal curve, or an area under the normal curve of 0.997. Let's go even further. All right, let's. So kind of wrap it up a little. What we do in a stats class is move on to making confidence intervals. So the more area that you get under that curve, the more confident in that you've selected a value in that that you're interested in. See, I'm starting to ramble. Anyway, we would move on to building confidence intervals. The larger the interval, the more confident you are that you've gotten that probability you're interested in. Okay, I'm kind of going to end it there. We're going to get into review problems next week. And again, after this next test, we're going into something called graph theory, where we won't come back to any of like mean or standard deviation or normal curve. We're going to leave this all behind. Okay, thank you everybody. Have a good day, and let me know if you have any questions.